VEXTEC has developed an innovative patented technology called Virtual Life Management, or VLM. VLM is now extending conventionally used finite element analysis through the creation of a component virtual twin. A virtual twin is exercised through the internet to forecast and interpret fleet durability, even before the first unit is manufactured. This process demonstration will convey how the VLM technology works. Let's overview the key element of the VLM simulation process. A demonstration component, a gear, will be used in illustration. We'll first show how VLM extends the FEA work used in standard component design. Our VLM simulation processing takes place at the level where damage actually occurs, the microstructural scale. The in-service degradation for each of the millions of component grains is simulated. The results are then aggregated back together. The life prediction results are mapped back to the FEA mesh. The life for each FEA element is statistically combined to predict component durability. The entire process is then repeated for all the thousands of units planned for the fleet. This process demonstration starts with the gear component to be analyzed. A gear has many teeth. The simulation will initially focus on a single tooth. Most companies use CAD to lay out the dimensional aspects of a design. Shown here is a conventional CAD layout tooth. VLM builds on this information. In addition to CAD, most companies have the ability to analyze a design using finite element analysis. This shows the type of standard FEA mesh pattern that might be applied to a gear tooth. Through FEA processing, stress patterns are predicted, and yellow areas are indications of high stress, and the dark blue area represents the lowest stress. VLM processing occurs within every element of the FEA, so we'll select one element as the starting point. VLM extends conventional FEA by superimposing a natural 3D grid within each element of the mesh. The 3D grid is defined by the manufacturing process used to create the material. As shown, the grain structure has inherent variation, which is representative of the material within the actual component. The FEA element stress is translated on the 100 to 500 grains that make up the 3D material representation. VLM conducts an analysis of all the grains in the 3D representation. This illustrates how the analysis starts with a single grain. The grain stress is translated into energy with pre-configured physics-based damage equations. Damage is simulated for every single grain as a function of time or cycles. The damage simulation determines whether the energy built up within the grain is sufficient to initiate damage. If so, the grain simulation determines whether the damage grows into grains to result in complete component failure. All of the simulation details are recorded. In this example, the grain life is 19,678 cycles. The failure statistics for the initial starting point grain are correlated back to the 3D material representation and evaluated. Ultimately, all the grains within the 3D representation will be evaluated. The results are statistically processed to predict the starting point FEA element life. In this case, the element life was determined to be 17,561. A similar process is used to determine the element life for each and every FEA element. All of the FEA element lives are statistically processed to determine the starting point gear tooth life. This entire process is repeated for each of the gear teeth in the component. The process is completed. All of the individual gear tooth lives are statistically processed to determine the probability of failure for the entire gear component. In the real world, a gear manufacturer doesn't produce just one gear. They typically produce thousands. The VLM simulation is repeated for the number of components to be produced for the planned fleet launch, 1,000 in this example. This demonstration shows how our new, innovative VLM technology builds on what most companies already provide. The designer lays out a mesh pattern and the software applies a single equation throughout the mesh to predict an answer, stress for example. VLM starts with the FEA mesh layout and then superimposes a natural mesh, reflecting the actual material processing. A multitude of damage equations is applied to simulate in-service degradation. The VLM output is a statistical forecast of fleet durability, which includes the detailed simulation statistics of every grain within the component. For more information about our VLM technology, visit our website at vextec.com or contact us by phone at 615-372-0299.